Section B. Kepler's laws of planetary motion.
Upon careful observation of planetary motion, scientists realized that the planets have common regularities.
So Johannes Kepler, an astronomer and mathematician, stated these regularities in his laws of planetary motion.
Kepler's first law is that each planet has an elliptical orbit with the Sun at one focus.
An ellipse is a plane figure such that the sum of the distances from any point on the figure to two fixed points in the plane is constant. Each fixed point is called a focus. The longer line segment through the foci is the major axis. Half of that is called the semi-major axis, and perpendicular to the major axis going through the ellipse's midpoint is the minor axis. Remember this? Well, Kepler's second law states that an imaginary line that connects the Sun to any planet sweeps out equal areas in equal times.
Kepler's third law, and you'll probably use this a lot, states that the square of the planet's orbital period is proportional to the cube of its semi-major axis.
Remember, we learned about an object's period in the gravity-packed world of physics, Part 1. The period, capital T, is the time it takes for an object to complete one orbit. The period, measured in seconds, is how long it takes for a planet to complete one orbit around the Sun. Or we can use it for any object that orbits around another, like two satellites. So Kepler's third law states that the square of an object's orbit around another object equals a constant times the orbiting object's semi-major axis cubed. We can write this as an equation where the constant has been found to be 4 pi squared over the gravitational constant times the mass of the body around which the object orbits.
For us, then, T squared equals 4 pi squared over G times M times A cubed, where T is the period of the planet, G is the gravitational constant, M is the mass about which the object orbits, and A is the orbiting object's semi-major axis, or its orbital radius.
Got that? T squared equals 4 pi squared over gm times a cubed.